In this lesson, we are going to talk about the 4 paths to evolution. So our objective for this lesson is to be able to understand the mechanisms by which species change over time. And by the end of this lesson, you should be able to develop a cause and effect model for the process of natural selection. So these first couple of slides that we're going to go over do not have any notes that you have to write down. It's just a little bit of background information for you before we really jump in, okay? So don't panic, there's nothing to write. Evolution is quite simply a process of biological change in a population of individuals over time. This biological change over time makes the descendants, okay, within that population genetically different from their ancestors. So to kind of sum it up, evolution is just simply a change in a population over time. Okay, that's what we mean when we say evolution. Now, evolution can technically occur kind of at 2 levels or 2 scales. You have microevolution, which occurs on a small scale, typically affecting only a single population. And then there is macroevolution, which is evolution on a larger scale that is affecting changes in multiple species, right, across kind of multiple populations. So just kind of a slight distinction there. If we talk about evolution, we of course have to talk about Charles Darwin. He was an English naturalist. The term biologist didn't exist back in his day, so he was known as a naturalist, but today he would be a biologist. Basically, Darwin is famous for a couple of things. Number one, he went on a voyage. He had a lot of money and spare time, so he decided to travel around the world, and his most famous stop along this voyage was the Galapagos Islands. On these islands, Darwin saw just tons of different species. You had birds, you had tortoises, right? And all of these different species had very specific characteristics for that island that he found them on. So even if he traveled to 3 different islands within the Galapagos, the finches or birds that he saw on the 3 different islands all had different characteristics. These observations are what allowed Darwin to develop, his now famous theory of natural selection, or theory of evolution by natural selection, as essentially a way of explaining the mechanism for why he was seeing all of these different adaptations or all of these different characteristics within these populations. So natural selection is one of the driving forces of evolution. Basically, Darwin said that natural selection is when organisms with the best trait will survive and reproduce more than others that don't have that trait, which will then cause a change in the population over time, right? Because again, we said evolution is when you see a change in the descendants, right, compared to their ancestors. A lot of the times you'll hear natural selection referred to as survival of the fittest. Now, fitness is not who's the strongest or fastest or smartest or tallest. Fitness is simply a measurement of how well an individual survives within their environment. If the environment changes, fitness changes. And so natural selection changes. So just because you were the best or you had the best adaptation one generation doesn't mean it's going to be the best in the next generation if the environment changes. Okay? So we're going to start by taking a look at natural selection and 3 other mechanisms that are the driving forces for evolution. Okay? All right, so we're going to start with natural selection, right, which again is a very large driving force for evolution. There are different types of natural selection that can occur within a population, and that type of natural selection depends on how the environment influences a specific phenotype or trait within that population. So we're going to look at the 3 different types of natural selection that can occur as, again, driving forces of evolution. So our first type of selection is called directional selection. So directional selection is when you have one phenotype that is favored by the environment. So, for example, right, most of the moths, right, can have light colored wings, but the moths start to disappear, right? There's a change in the environment. Over time, the moths start to develop darker colored wings, okay? So this is directional selection because the phenotype is being pushed from one extreme to the other, okay? So from light colored wings to darker colored wings, okay? So you have a shift with the phenotype that's being favored because of the environment. The second type of selection is called stabilizing selection. Stabilizing selection is essentially when the average or the intermediate phenotype is, the best trait for that environment. So a really good example of this is actually baby birth weight. So babies that are born with a low birth weight or an extremely high birth weight tend to not survive as much as individuals that have, let's say an average birth weight, right? So this is stabilizing selection, right? Because we're going for the intermediate or the average. And again, if we think about it, a low birth weight could mean that maybe the baby was born premature, so maybe their lungs hadn't fully developed, can't survive without lungs. Or it's a very high birth weight. So maybe, again, the baby's already got some type of illness that they're having to deal with. So stabilizing selection goes for the average of the phenotype. And then we have disruptive selection. So this is the third type of natural selection. Disruptive selection occurs when you have both extremes that have some type of advantage within the environment. So in this example, we're talking about snakes that live on rocks, right? And if they're gray, right, they survive. But right over time, right, they're being pushed to one or the other extreme. So snakes that live on grass and are green will also survive. So move that. So you can be right gray and survive, or you can be green and survive. Okay, but if you're anywhere in between, maybe you're speckled, you have gray and green, you are going to be visible to predators, so you are not going to survive. So in this case, being the average sucks. You're not going to make it. You want to be one or the other. So that is disruptive selection. Okay. Now, in order for natural selection to occur, there are a couple of requirements that are needed. Okay. But we're going to go ahead, we're going to pause here, and we'll pick this up in the next session. Okay.